Hello, this video is section 2.3, Measures of Central Tendency for Data. And the three main measures of central tendency are mean, median, and mode. Now the mean, which is the term we use in statistics, is basically just an average. We don't call it average, we call it the mean. Now there's two types of mean. Population mean, if the data set represents a population, and it's defined as a Greek letter that, it's called mu. You look at it, it looks like you can't decide whether it's a U or an M, but it's not a traditional letter in the English alphabet, so it's a Greek letter mu, and it's calculated as the sum of that's your summation symbol we've talked about in previous lectures. You add up all your values and you divide by how many values n in your population. Use capital N for population size. Now sample mean is denoted by this X with a line above it, which we just call it X bar. And it's essentially the same formula. We use lowercase n for the sample size versus capital M. There are some situations in statistics that we're not going to cover, but there are formulas where you would need two different n's. We're not going to worry about that, but there would be a difference between capital N and lower n. But in our world, basically n means how many values do you have. So basically adding them up and dividing by how many you have for the regular sample and population mean. We're going to learn something called weighted mean coming up a little bit later, which will be different. But all right, so this is real simple. So find the sample mean, just telling you the sample mean, so I'm using X bar as my notation for 12, 8, 3, 7, 6, which is 5 values. You add them up, divide by 5. And you get 7.2. Now here's another data set that I've just labeled as population. 5, 7, 9, 10, 5, 9, 10, 7, 13. So labeling it population didn't affect the calculation, just the symbol I'm using. I'm using the mu, but I'm still adding up those 5 numbers and divided by 5, and we get 8.8. Now we'll explore this deeper with technology here in a little bit. Now let's talk about median. Medians, well, like I said, we'll be using either the calculator or technology, but I'll sort of show you how it's done kind of manually here. The median is the middle value of an ordered data set, or it may not even be an actual value in the data set if we have an even number of values, which we'll learn shortly. So the idea, though, is that the median is 50%, half your values are below the median, half are above the median. So here's a data set. So very important, unlike the mean where you're just adding them up and dividing by how many you have, these need to be in order. Now when you use technology, they don't have to be in order because it'll take care of it for you. But if I want to find the median of 12, 8, 3, 7, 6, I need to resort these and say 3, 6, 7, 8, 12, and the median will be the middle value, which is 7. That would be the median for this data set. Now let's look at the next example. We take these numbers here in red, resort them in this order, and you got 9 right in the middle, so your median would be 9. Now we're coming up with a different situation. Both these examples had an odd number of data values. It's a little bit different when it's even. So now I kind of used a similar, okay, looks like I used the exact same data set here, except I added an 18 in there. That created a 10th number. So when you have an even number of values, you will not have one unique number in the middle. So the way it's calculated is it takes the middle 2 values and then you average the middle 2. You find the mean of those middle 2 numbers. So the middle 2 numbers are 9 and 11. So you just basically average those together, and it would be 9 plus 11 divided by 2, which makes the median be 10. So in these situations where it's an even number of values, it's very possible that your median is not going to be a value in your data set. If you have an odd number of values, it will be a specific number in your data set because it will be the middle number. Now let's take a look at how to do this in the calculator, and then also we'll see how to do it in Excel, which I have some Excel stuff coming up here in a little bit. But I can do it for this same example also, and also we'll see it in the MyStatLab homework. But I'll use this same data, or I can take another example, it doesn't matter. But so what we want to do is we go to Stat, Edit, and we're going to put the numbers in a list. Now, when you put these numbers in there, they do not have to be sorted in order. You can put them in exactly as they're given in the problem. So if I'm looking at this example 4 up here with those numbers, so I'm going to hit 3, hit Enter, 11, 2, 9, 1, 17, 6, 15, 11, 18. I'm going to hit Enter. Now when I have all those numbers in my list, I'm going to go second, quit, which is second, basically hit the mode because the quit's the blue function right above the mode. Takes me out of there. I'm going to go back to Stat. Now instead of choosing Edit this time, I'm going to choose Calc. I want to choose one var stats, and then if it's already set up to be an L1, so if you just put your data in L1, you're good to go. We won't need this second thing right now, but we will be using it in a later chapter where we have 2 sets of numbers. But right now, so if you just leave it as L1, it'll be the default. If not, if you have it in a different list, you'll have to change that list. Come down here and hit Calculate. And now they're using the X bar symbol, but obviously it would be the same either way. But up here at the top, if you wanted the mean's right there, 9.3. But so whether it was sample or population, it's giving you the correct value. And you come down here to get the median, and there it is, MED. MED is your median, and it's 10. Of course, that output screen is already right here in the notes, but I wanted to walk through it anyway. And there, I scroll down below you arrow down to get everything in the picture, but there's the median at 10. So now a lot of times in data sets, especially larger ones, you're expecting the mean and median to be pretty close to each other, and that's pretty typical. Now, but what happens to like a little bit different here, like we're saying we had a stat exam, the mean being the average, the median being the middle value. So let's say the mean was 78, but the median was higher, it was 84. Median being 84 means that half the scores were above 84 and half were below 84. Now what would this imply to you? Well, that would tell me, looking at this, that if the average was lower, that meant there were some low scores, but that would affect the mean but not the median. And meaning, in other words, those low scores could just be due to being the median being reasonably high at 84. That just means you have people that are unprepared. So an instructor might look at it and go, well, maybe my test wasn't that difficult. It's just that 2 or 3 people were unprepared and did really poorly. But the median being 84, that tells you got half the scores were better than 84. So maybe it was okay. Now this part in red is pretty important, and it's going to come up, in the next section 2.4. We have some other measures we're looking at here. But what's interesting about people might want to use the median is unaffected by outliers. We mentioned the word outlier before, and we'll keep talking about outliers. But outliers are basically extreme values. So the median will not be affected. So I'm going to kind of freehand draw something in here, and I'm going to just put just show you an example. I want to put like 1, 3, 7, 10, and whatever, 11. I'm going to come down here and put 1, 3, 7, 100, and maybe, I don't know, 700, point being. Now you calculate the means for these two data sets, they're going to be way completely different. Because that 100 and that 700 is going to just change the mean like you wouldn't believe. But look at the, because they're already sorted, look at the median though. The median would be exactly the same. So though changing those last two numbers to be exceptionally larger had no effect on the median, but it would have drastically affected the mean. So that's what we're saying when we say the median is not affected by outliers. Extreme values, high or low. So there's one I kind of made up with just some scores, and you can see there was like a 10 and a 20, and that made the average 74, but the median would actually be the average of these middle two. So 87.5, that tells you half the people did above 87.5, half did below. And once again, as an instructor, I'd look at this, and I would not look at that 10 and 20 as my exam being too difficult. I would look at it as saying these people were just unprepared. That's the best explanation. But anyway, all right, so here I'm mentioning outlier again. Outliers are values that are far removed from the data set, like you got these little batch of numbers right here. And that 35 would be considered an outlier because it's pretty far away from the others. The median, it didn't affect the median. I mean, that 35 could have been 11. It has to be bigger than 10, though, for this median to be the same. But if it's anything bigger than 10, that would not affect the median being these two, 7 and 8, average for 7.5. It would only affect the mean. Now, mode. Mode is the data entry values that occur with the greatest frequency, provided it occurs at least twice. That's the key. It has to. Now, mode is the only one of these three that can apply to both quantitative and qualitative. It's the only one that works for qualitative. You could just look at the frequencies. Now, in 2.2, I can go bring that back up, I guess. Yeah, I can bring it up real quick. You can have mode can be word answers. It's the highest frequency of something chosen if it's qualitative. Let's see. Scroll down. Where's pick those 5 types of cars or whatever. Let's see, they were. Yeah, here we go. This is what we're talking about. So a mode can be a word answer. So in this one, you see these frequencies. The most frequently, the highest frequency was Toyota. So Honda. I'm sorry, Honda had 58, Toyota had 52. So actually Honda would be the mode for that one. So modes can be word answers. Mean and median, they're always numerical. They can't have qualitative data. Now these examples, of course, here are numerical. That's what I was saying. Mode can be for either quantitative or qualitative. So we got 6 numbers here. All numbers are different. Nothing repeats. No mode. It's got to repeat to have a chance to be a mode, but don't overthink this too much. Now this one, for example, yeah, there are 2 6s and there are 2 1s, meaning 6 and 1 have a chance to be the mode because they repeat. However, there are 4 7s. So ultimately 7 appears the most times, therefore it is the mode. And you can have more than one mode also. Like this one, look at 4. We have 1, 2, 3 4s. And then 1, 2, 3 5s. So you have modes plural here. 4, 5. They're usually separated by commas. So yes, you can have, that's also, when it's 2, that's also known as bimodal. So, okay, that's basically all there is to mode. And we'll, like I say, when we see the homework, we'll be looking at. Now, this is from that. Now, I'm mentioning it if you have Excel, and let's go from the last one. I'm going to go over here to data. Now over here to the right is this thing called data analysis. You may not see that. It's an add-in. It's a free add-in or whatever, but you have to go. And I think I mentioned in the notes there that I did it, via YouTube video, because it might be a little bit different whether you're using a Mac or a PC. On a PC, I think you go to File. I think it's Options. But you can Google that. Add-ins, I believe it is right here. Click OK, I guess. Well, that didn't work. Or maybe it's something with tools and options. But you have to add that in. Let me double check one more time. Oh, maybe I missed something down here. No. I thought it was add-ins. Oh, yeah, here we go. I must have clicked on the wrong thing. It's the Analysis Tool Pack. So you'd want to highlight the Analysis Tool Pack. And what's weird about this, before you think you could just hit OK, but I think you actually have to hit this Go right here first. Yeah, and you don't have, if those boxes are all checked, that's fine. You only really need the top one. And then once you click OK, see, mine's already there, so it's already there. But anyway, it'll pop up right there in that spot with the data. We'll try a fresh example with the MyMathLab. So, but anyway, let me look at this now and just kind of show you. Now, there's going to be just one way to do it. I'm going to show you how to use. Well, actually, I got both ways, I believe. Yeah. You can do mean, median, mode, just straight commands, which is fine, but I'll show you that data analysis thing also. So if you look at this, and there's that same data we had, I entered them right in there. The mean is just the average command. Average command A1 colon A10 for those 10 numbers. Median, you do equal, you always have to put equal in front of it. Median A1 to A10, there's your median. And mode dot mult, put mode dot mult, because that way if there's more than one mode, it'll show both, like the one on the right. So this one just had one mode. 11 appeared twice. No other number appeared more than once, so it's the only mode. And it looks like I just slightly tweaked it here. What did I do? I changed, I added a 15 because I wanted to have a second mode. So there are two 11s and two 15s. So it didn't affect the median. The mean is different, obviously. Oh, the median was affected. I'm sorry, it became 11 instead of 10, excuse me. But mode mult gave us both modes, 11 and 15. So you can just use those commands. And I'll walk through the data analysis, but you go data analysis, you pick descriptive statistics, you just highlight your cell range, which I'll show you, and I'll show you what to do. Output range, you just want to pick some cell away from your data. That's where it'll start putting the output. It'll go down and to the right. You just don't want it overlapping anything else you want to use, and you have to click the summary statistics box, and then there it's got the mean. That was for the first set of data. I don't know what this does for. If it has more than one mode, I'm not sure. If it's the example I did, yeah, I don't know. Because it looks like I'm probably using this example here on the left, not the one on the right. So I'm not sure if it shows both modes or not, but you might want to just use that individual command. But it puts everything else along with some other stuff in there we don't necessarily need. But I highlighted the mean, median, mode. Yeah, obviously it's telling us it's for that first one. Yeah, 9.3, 10, and 11. But you might find it easier just to use those individual commands. All right, let's talk about shapes of distributions. We'll talk about continuous versus discrete data later. Sometimes they'll be smooth like that, or connecting bars for what's called discrete data. But anyway, now the name of this might seem illogical. Don't worry about that, because I can see how you might look at this and go, oh, well, there's more data on the left, heavier on the left side than the right, so wouldn't that be called skewed left? No, actually, it's the opposite. Skewed right is when you got more data, heavier on the lower end of the data. We just kind of have to go with that. We have to accept that. Skewed right is just the opposite. If there's skewed left is the opposite. That was correct, but skewed left is the opposite of skewed right, meaning there's more on the upper right than there is on the left. It's higher on the right side. Now, uniform versus what's called perfectly uniform. Perfectly uniform means every one of them is exactly the same. But we can call it uniform if all the bars here are roughly about the same height. Then we have what's called symmetric. Symmetric but not uniform, meaning uniform, yes, is symmetric, but we would pick uniform as the answer if it's uniform, not both. In other words, symmetric but not uniform and symmetric. Now, symmetric means that the graph, I did it with both curves and the bars. If you take the graph and you put a line right down the middle of it, it folds over. It's symmetric about the middle of the graph. It folds over. So like you put a line right here, that folds over one side or the other. Here's another one right here. It would fold over to be one side and the other. So here's a quick little question, which we'll see in the homework. How would you classify this distribution? It's heavier on the right, more value data to the right. So going back up here, that is skewed left. So that's really all we have to worry about, that, answering questions off of that. Now, this one on stem and leaf, and I think there's one like this in the homework. It's kind of, picture it like sticking out sort of sideways, and in a sense that, I'm going to copy this. I'll snip it over to another page. All right, where's my snipping tool? Yeah, there we go. And I'll show you what I mean. You're sort of looking at it as a sideways bar histogram graph. So you just kind of picture it like it's tilted on its side. I mean, you don't have to actually draw bars around it, but I'm going to draw bars around it just to show you. I wish I could actually make this thing rotate, but I don't think I can. So if but you can see the pattern if you look at it sideways and pretend like, you may not have to like tilt your head or anything, but so like, see, I'm just drawing little bars around them. Like I said, when we say symmetric, it doesn't have to be perfectly symmetric. So look at this sideways, and then look at it, and let's say I'll draw kind of a thick line right through here. And if you look at that, so it folds over to be roughly the same on both sides. So it's this one we would call symmetric. But yeah, we can do, I think there's one in the homework where it's going to be one of the skews, in other words. So if you saw the stem and leaf have longer leaf patterns on the low end here, that would be skewed right. And if you saw the leaves look longer on the high side, that would be skewed left. And then if all the leaves were about the same length, that would be uniform. All right, so it's kind of like you look at sort of a sideways bar graph. And there's the answer right there, symmetric. Now let's talk about weighted mean. Now, weighted mean is if you're trying to calculate an average, but for whatever reason that each value is not equal to the other. Like if they're all just equal values, you add them up and divide by how many you have. Now, the most common type of weighted mean that you as a student would encounter, and probably have encountered, is if you're taking a course and certain grades, have different percentages to them. So how would we calculate the average? If they're all equally weighted, which they are in this class, they're equally weighted, but if they weren't, you can add them up. You take them, and you don't really need this fancy formula here, but I wrote the formula anyway, is you take, because the sum of the weights for these problems, they're percentages, so they're going to add up to 100%. So on the bottom, that's going to be a 1 anyway, so you're just dividing by 1. There's other situations where that won't be a 1, but it would be for this. So we have this breakdown. Homework 15, quizzes 15, lab 10, midterm 30, final exam 30. So the scores in order: 92, 80, 100, 75, and 76. So you can then you just take each number and multiply by its weight and add it up. Like I say, I wrote right there, you're dividing by 1. So that's all you got to do. This might be helpful information for you when you're taking other courses where this does happen. You just take each number, multiply by its weight, and add it up. There's no fancy, really, Excel program that'll do this. I mean, I can show you an Excel command, but it's not a function. You still have to put the numbers in, and you have to make it do the multiplication, so it's not anything special there. But so yeah, you can just do this straight up in a calculator, any regular calculator. But here, what I was doing, I was just kind of showing the difference between it says, so here's the weighted mean. So you do all these, add them, this, and you get 81.1. But then I put in a what if scenario. Just what if they didn't have different weights? They were all equally weighted at 20%. If they're all equally weighted, you just add them up and divide by 5. And that's it. But like I said, maybe I'll show you, I think there's one in the homework we'll look at. Maybe I'll put it in Excel, but Excel is not going to do anything that creative for us. We're still going to have to make it. You're going to have to put a command in there that makes it multiply. But actually, that's probably good for me to show you how to do anyway, so we'll do that. But you can knock it out real quick with that. So, okay, I don't think I'd ask this one on a test, but I'd like to show it to you anyway. Now, we're just talking about the final, but this is obviously a typical kind of question, like what score would you need on a final exam to have a certain average for a course, the minimum score you would need to get to that average. Well, this time your unknown here is not going to be the final average, because we already know 80 is what we're shooting for. It's going to be this particular score right here. So you take all those other scores, and now this final is an unknown, so it's an X times 0.3, and then we know 80 over here, so we're essentially just solving for X. So if you multiply all these out that I have a little grouped together, add it up, you get 58.3, plus this right here is 0.3 times X, and just subtract basic algebra, subtract 58.3 to both sides, and you get 0.3x equals 21.7, divide by 0.3, and then you get, I just changed it to 72 roughly or whatever, but 72.33. So it looks like you need a 72, and of course anything higher than that, but that'll get you to your score of 80. Of course, you could also set this up in a spreadsheet and leave that value unknown, and you could just, I can show you that too, but you could just type in different numbers. Yeah, I might do it, and then you could see what the new average would be. But that's how you solve for it precisely, is by doing that. Another example of a weighted average is calculating GPA. Now we don't divide by 1 this time. You divide by so basically it's the number of grade points divided by the number of hours taken. These are the weights. So let's say we have these 4 classes with these 4 grades related to their hours. So a 3-hour A, 3 times 4 gets you 12 grade points. A 3-hour C, 3 times 2 is 6. 3-hour B, 3 times 3 is 9. A 4-hour A, 4 times 4 will be 16. You add that up, and you earned 43 grade points. So even though these are letters, these are actually numerical values representing those letters. So it's like a 3 times a 4, 3 times 2, 3 times 3, 4 times 4. You get 43, then you divide that by the hours taken. So for that semester, you had 43 grade points divided by 13 hours, and you had a 3.31 GPA for that semester. So that ends the lecture portion of this video. So let's pop over into the MyStatLab homework, pick out a couple 3 goodies here. I think I'll go to that weighted average problem first. So I try to pick anything that looks like some of these things. I might do one basic mean median mode here just to show you. There's 2 of them. There's 2 of them right there, so I'll come back to that. Here's a picture of a skewing one. That shouldn't be too hard if you go back and look at my definitions. Here's weighted average. So you can decide if you just want to take the numbers and go right there. You can go 90, and keep in mind, multiply, make those decimals, that's percent. So 90 times 0.15, 82 times 0.10 in the calculator, so forth and so on, like I did in that example, and that'll get your average. But I promise you I would show you this in Excel. But obviously nothing wrong with just popping it in the calculator. Excel is going to do a lot of nice things for us, but we don't necessarily need it for everything. I guess Excel is probably good to know how to use, because that's most likely what you would be using in professional environments, so it doesn't hurt, in other words. So what I got to do is I'll just pick a cell over here. I'll move it over so it won't be against that column. Now I can change all those to decimals, or I can just divide by 100. So now I'm going to create a column where I'm multiplying I'm going to go so that the first score of 90, what position it's in B2, times, which is above the 8. And I would just put C2 if it was already a decimal, but I've got to, in fact, I could change those. I could change those to percent. But I'll just do it like this. I'll make it divide by 100, and that'll take care of it right there. So I'll do this, and I'll grab the right-hand corner, the bottom right corner, and click and drag right there. And that gives me all of them. So I'll come down here, and I'll do like I did in another video. I'll go down one more, and I click over here for auto sum, and right there at the bottom, it'll give me the number. Okay, just for grins, I'm going to boldface this. That's not important, but so there it is. That might be quicker than the calculator, actually. Let me come over here real quick and just show you. So that way, if you want to yeah. Even though I'm not saving this in the notes, you'll be able to pause the video and look at these if you need to. I hate when they're not lined. Let's see. There we go. So we'll copy this down. It'll probably show the sum down there, I guess. Yeah. So it sum actually did that. So yeah, that little auto sum just does the sum command for you. So you see, it's each B times the appropriate C, then divided by 100. So I'm going to try 91.4. Let's see how we did. Got it. Excellent work. I'm going to jump ahead towards some of these couple of ones at the end I thought were interesting. This is a pretty good one, I think. The last two might be the best two instead of just. All right, I could go back and do maybe go back and do a regular mean median mode before we move on. But these two are good. Then I can go back and do one of those. That's fine. I think I promised you the data analysis. Yeah, both of these are good. So do these two, go back and do one more, and that'll be it. So let me take the completed off of here. All right, we're going to do a little frequency thing here. We've done this in 2.2. Or was it 2.1 maybe? I forgot already. I think it was 2.1. Let's do these, and let's all right, I'll check on the enable editing, zoom in on this a little bit. So, well, let me highlight. How many do we have here? We're going to use our friend the sort command. Well, let me cancel that. I should have clicked on that sort. The other sort was just if you wanted to do some fancy stuff there. There they are. So what do we have? Let's see what it's asking. And 5 classes. Well, you can see there's 5 classes. And let's do our calculation. Let's look at the highest minus the lowest that we've done before. The largest value is 76. The smallest is 62. I can do that either here or in a calculator. I mean, or in the calculator, but you can use the Excel. You know, I can go equals. I got to use parentheses here. Oh, I think I hit negative. Equals 76 minus 62. Right there. Close that off. Divide by 5. So whether you do this or the calculator, there's no reason why you can't just change back and forth at any time. 2.8, that means my class width is going to be 3. All right, so we've done that before, but there's actually something new at the end of this. It has to do with skewness. 70, I think skewness, or is it stem? I don't know. Let's see. 62. So we go these 3, so we'll go down by 3, 65. I'll just do it this way. You can go across, it doesn't matter. 68, 71, 74. So if the second class starts at 65, that means this one ends at 64, and these will go up by 3. 67, 70, 73, 76. Counting time. Oh, midpoints. So add them together, divide by 2. I'm not going to show you that in the calculator. I know you can do it, but it'll be 63, 66, 69, but 72, 75. Let's get the frequencies. We've got to count how many between 62 and 64. I won't do all color code and fancy stuff. I see 4 of them. It'll be a 4. 65 to 67. It looks like you can check the count feature down there if you need to, as I've showed you that before. Count is 7, but you can kind of count them and hit this way and see that it's 7, but I wanted to remind you of that count feature. 7. 68 to 70. Looks like we got 8 of them there. '71 to '73. Yeah. Was it doing something wrong? Yeah, there we go. Sometimes I press it too quickly or something. 71 to 73, that looks like 8. And then the last one's going to be 3. I want to come back to it. 8 and then 3. Let's see how we did. Wonderful. Okay, just got to pick the correct frequency distribution. So it goes 4, 7, 8, 8, 3. You see the third and fourth one are tied, so I like that one. We can zoom in on it if you want to see it a little bit better. Can I zoom it? Okay, there we go. Yeah, 4, 7, 8, 8, 3. I like it. Got it. Okay, it's okay. Let's look at the. Oh, negatively and positively skewed. Okay, yeah, I wish it didn't have those as answer choices. Those aren't going to be the answer anyway, but those are essentially left and right skewed. But that's, you'll never be asked a test question that has that wording. It would be either left or right. I should have probably defined those earlier, but I'm not put them on a test. But anyway, long story short, that's actually, it's pretty close to symmetric. Not perfect, but you see it's not really too heavy to the left or to the right. It's certainly not uniform with height consistent, so we're going to go with, unless it's tricking us and being none of these, but I think symmetric ought to be okay. Yeah. Not perfectly symmetric, but close. Fantastic. So I want to do this one. Mean and median. Let's get our new sheet up here of data. How many we got in this one? 30 of them. Let's zoom in a little bit. Okay, mean and median, we don't need any kind of sorting or anything like that. Now I'll put the commands in here, and I'll do the formula text so you can see the commands. A1, A30. Oh, not mean. Typo. It's average. Excel, yeah, I'm thinking, we call it the mean, but Excel uses the function average. Excuse me, and I already said that. Okay, there we go. And let me put this in here. Well, I'm glad that didn't take too long to figure out. Didn't have to stop the video or anything. I can leave that mistake in there and not worry about it. Yeah, so you see that's the command. I'll have the next one ready here. The next one, though, is median. A1. Or actually, I think you can probably highlight, select them also, but either way, there's several ways to do this. So there are the two commands. Now you can see the commands. So if you need to pause the video and look at them at some point. Let's see what they want here. And always got to pay attention to what it wants for the decimal places. Sometimes you can have multi-parts to a problem. Might want 2, might want 4. We just do whatever it tells us to do. On a test, that won't be an issue. They'll all be rounded. You just pick the one that you can see is the closest answer, so it won't be that picky. But here it's picky. Let me double check. I think it's 35.033 if we go to 3. Yeah, 35.033. Fantastic. The median is 38. Beautiful. Stem and leaf. Okay. Hopefully we can pinpoint it pretty quickly without having to do the entire thing. Like it looks like, oh yeah, even for the first one, they're all different for the first one. So you actually can get away with this just by doing the first one. But yeah, like I said, that's okay. I don't mind that because I'm confident you're gonna. Now I'm gonna sort them, but I didn't have to sort them to do these commands. Data. Sort, or let's sort like that. Let's see. And so the stem, and I can make these go sideways if I need to, but I don't need to. The leaves will go 1, 2, 2, 4, 6, 8. Oh, what's the matter with me? 1, 2, 2, 4, 6, 8. It's A. That's the only one that has 1, 2, 2, 4, 6, 8. Now, how about this one? Like we talked about the example that was in the notes, you know, where you can look at the stem and leaf even though it's sideways. Although this one's pretty easy to see, the leaves are all the exact length. So even if they were just like 1 or 2 off, you could still call this uniform. This one's actually perfectly uniform, but even if one of them was sticking out on one side, you could still probably say, but it's clearly uniform. But it's also symmetric, but that's what I'm saying. If it's uniform, you choose that first over symmetric. But yes, you can argue that uniforms are symmetric. All right, that was the end of this one. I'm going to show you. Actually, I'm going to show you the data analysis command for a different example instead of this one. I think that also asks mode in there too. So, one thing about this problem, I kind of want to save time here. I showed the one example. This has too many numbers. I don't want to put this one in the calculator. I'm sorry about that. I don't feel like entering 30 numbers in the calculator. But that's, if you prefer the calculator, that's great. But for the example I did in the notes, there was only so many numbers there, and hopefully, you can look back at that example and do that to see how to do it. If you want to make sure you use the calculator instead of Excel, but it sure was better with Excel in this case when there's more numbers like that. But if you want to take all 30 of those and put those in the calculator, you just do the same thing. Stat, edit, list. Oh, I will show you one thing though in the calculator without doing that. This might, let me help you with this. Let me clear this. And let's say I want to go stat, edit, list. And I want to put in some new numbers. Now, if you're putting in more numbers that are already there, you can just type directly over them. But if it's fewer numbers, you'd have some number. Instead of going through and deleting all the extra numbers, you can clear the list. Now, to clear the list, you arrow up to the top, and it's weird because you hit the clear button, but nothing happens. Literally nothing happens when you hit the clear button. But then you move the arrow down, and then they're all gone. That's weird to me that it doesn't clear when you hit clear, but as soon as you move that cursor arrow, it's gone. And you can put your new numbers in there. So let's go back to, I'm going to just do a basic mean median mode. I'm going to show you how to do it. The last one, I guess, let me do real quick for this data that we just did. It didn't ask it in that problem, but let me do the mode multi just to see what, yeah, let's just do that while we're here. Mode, mult, A1 to A30. So there evidently is, oh, forgot to copy this down so we can see the command. That means it'll give us more than one if there is a mode even. Okay, you see that. Look at the 38. There's 3 38s. I see a couple of 46s, a couple of 49s, 20s. I see several repeats, but none of them, not 3 is the most. So the mode is 38 because it had the most, the 3 of those. Okay. So there would have, if it would have asked for the mode, we could have got that pretty easily. This one's fine, or I'll do the one before it, either one of them. So here's a little data set. Now this one it's fewer numbers. You might want to put this one in the calculator. But I want to show you the, obviously you can do what I just did right there on the spreadsheet. That's about to go away here. Do it that way, it's fine. But I want to show you the data analysis command. If you've already, after you've already, assuming you've got it loaded and everything. So, add the add in part. And once you add in once, you never have to do it again. So I'm going to go data, data analysis. I want descriptive statistics right there. Descriptive statistics. Range, and I'll go over here. I'll drag them down and I'm highlighting them. I can just type them in there as A1 to A10, but that'll highlight them for us. Output range, so here's what I was talking about. I'll pick that cell I've got right there. I don't have to put it in. I'll just put where I want it to start, C1, because that way it'll go down and to the right, so it won't go over my data there. It won't block my data. So just anywhere, as long as it's going to go down and to the right. And then I have to check this box that says summary statistics. So I'll leave that there. So in case you need to pause and get a look at that. So let's look at what we got right here. So mode NA means we don't have one. I'll just kind of make these colorful here. Not that you need to, but here's the median. And I'll highlight NA, just means no mode. A lot of stuff, we'll be talking about standard deviation and sample variance. A lot of this other stuff we don't really need. It's kurtosis and the skewness. Kurtosis is a funny word. Sounds like a medical condition to me. Yeah, doc, my kurtosis is flaring up on me there. I think I need to have it looked at there. Might be a good excuse to get off work one day or something, call in sick with kurtosis, and hope your boss doesn't know anything about statistics. All right, anyway, okay, what do we got here? So, enough of the humor, if that's what I call it. 51.8. Fantastic. Median. Like I said, you don't have to do the data analysis. I just want to show it to you. You can do it exactly the way I did the last example with the individual commands. If you don't want to mess with all this, no problem. I just wanted you to know it was available. No mode. Now, I don't know what's going to happen. If I remember correctly, I believe that other example is, let me show you. Yeah, this should be okay for the, yeah. If I remember correctly, let me show completed. You'll get different numbers when you do it. Yeah, it's got two modes, and I'm kind of, well, I kind of want to do this now real quick because, well, I'll just do new numbers because I want to see what mode multi, that command will get you both your modes. But I'm dying to know what data analysis is going to show me here. So let me just do, I'm not even going to enter the answers in or anything. I'm just doing this real quick to just see what the mode says. So I'm not going to type them in and get my happy check marks and make myself feel good and all that kind of stuff. I just want to do a real quick data analysis on those 10 numbers because I just want to know out of curiosity. Data analysis. Descriptive statistics. This time I need to, it's B1, B10, just kind of, well, maybe, I wonder if I can highlight them first. Well, it didn't, I guess I could have just typed in the new ones. Well, let me do this and just leave that there and see what happens. Data analysis, descriptive statistics. It still thinks it's a, okay, I'm just going to type them in there. I don't know what's going on, but I'll just put B1 to B10. It would help if I actually hit the colon command. God, it's so small I can't see it. I keep hitting. All right. I think I got it. Output range C1's fine. Summary statistics. Well, let me insert it. I didn't mean to put it right next to that. I should have put it in D1. I can come over here and insert a column so I can see it. Oh, no good. No good for this command for mode. No good. It only gave you one of the modes. So don't, okay, we learned something. Don't trust this for the mode. There's more than one mode. Yeah, I think we're going to go mode mult, and that should give both of them. See, we're learning here, aren't we? Wait. Oh, it's B. I keep thinking everything's an A, and that's one of those letters. It's B1 to B10. Yeah, you see it gave you both. Okay, so there's how you get your mode, because that one's definitely going to have two modes. Now I could go do the one that we just did before this one. I can put them in the calculator if you want. I guess it wouldn't take that long. That one doesn't give, I don't think the calculator gives, yeah, I can put this in there real quick. I don't think it gives mode in the calculator. So, yeah, we'll do this real quick and then that'll be it for this video. Of course, you can always stop right here if you've had enough, but this will be the last thing I'm going to do. I'm not going to say anything magical. 31, 67, 71, 70, 79, 47, 34, 41, enter. I'll go second, quit, and I'll go stat, calc, excuse me, 1 var stats. Same, let's stay with L1 there. Yeah, mode's not in here. So there's your, at the top, there's your mean at 51.8, and then you scroll down, there's your median's 46. Yeah, so no mode, unless there's a mode function in the calculator specifically. Like if you go second 0, that brings up the catalog of all the functions. There are a lot in there. If I go second, well then again I wouldn't, well, okay. Mode, I can get to the M's by choosing the letter M quickly here. Let's see if I can get alpha. Where's M? Right over there. That didn't work. Alpha. Okay, fast forward me to every function with an M in it. Well, it's got mean and median here, so it might have mode. I don't know. No. I don't know what, okay, mod, that's not mode. All right, well, so, okay. So the calculator's not going to do, you can look at it and figure out the mode, if the data set, you can sort them and see which ones repeat. You can look at it visually. But you think I'm saying, you can do some things in the calculator, some things in Excel, whatever makes you happy. But mode multi looks like that's, so especially if it's got more than one mode, that's the best command so far for mode, but for sure. So, all right, with that being said, we're going to close this video off. The end of measures of central tendency.